So here is again a question about motion in the free fall. And it's a free response question or long response question. Let's see how we can do it. So a stone is thrown vertically up from an edge of a cliff which is 35 meters high. So they've given a diagram for us to help. So this is a cliff 35-meter high from the sea, and the initial velocity of the stone is 8 meter per second. Okay, so my u is going to be 8 meter per second. Okay, we like to write initial velocity as e, right? We have to find the maximum height of the stone. So of course the stone will go up to a certain height and then will stop because our acceleration due to gravity is downwards, right? So it is downwards, so it is going to keep on reducing the velocity, and after some time it will stop. Okay, so let's solve that part first. So part A, our initial velocity, so we are going to write in the usual way, uv as at. My u is upwards, so we call it 8. V, which is the final velocity at the top, is going to be 0. Okay, that's what it means. The final height it will achieve when the velocity is 0. And my acceleration this time is downwards, which means it's a minus 10. Okay, and we have to find the maximum height, which means we have to find s. We have been given u, v, and a, so we can very easily find s. The s t is not included. The only equation we want to use straight away is going to be v square is equal to u square plus 2as. V is equal to 0, u is equal to 8 into 8. So I'm just going to write like that, plus 2 into minus 10 into s. So this will go on this side, so this will become 20s is equal to 8 into 8. Okay, my s is going to be simply 64 by 20 or 3.2 meters. Okay, so 3.2 meters, maximum height attained by the stone from here. So this height is 3.2 meter, but it is already at a height of 35. The maximum height is going to be 35 plus 3.2, right? So this is 3.2 plus 35. This is going to be 38.2 meters, right? So don't be in a hurry to write this as an answer because we have to add this 35 meters. This is 38.2 meters. Now the time when it hits the sea. So now the stone has gone up, right? And it comes down, falls down. We have to find how much time has been spent to hit the sea. Okay, now we can do it in 2-3 ways, and I want to illustrate all of that, right? So I'm going to start again. So we are going to throw this with the initial velocity u, which is given to be 8 meter per second, and then the stone goes up, let's say the maximum height point m, and then finally falls down to the sea, which is s. Okay, and we have to find this whole time, right? So we can find the starting point from the whole time is going to be part a to m plus time spent from m to s, right? We can find them separately and simply add them up. Okay, so in the first part we already found the distance. So instead of finding the distance, we can find the time as well. In that case, we have been given u, so from 40 to am, right? U is equal to 8, v is equal to 0, and my a is minus 10. Okay, so how much time it will take to go there? T is what we have to find because we have been given 3 of them, and s is of no interest because for this part we can simply use v is equal to u plus at, right? So this is the equation where our s is missing, right? So we can put v is equal to 0, u is equal to a, 8 is equal to minus 10, and this is time. It will go on that side. So this will become 10t is equal to 8, and t is going to be 8 by 10 or 0.8 seconds. Okay, but mind you, this is the time when it is going up. We still need to find the time when it is coming down. Okay, so how do we find the time from coming down? We can write separately for the motion from t and s, right, from the maximum height to the sea. My initial velocity now is going to be 0, right? My acceleration is again going to be in this direction. So now this time we are going to take it as a positive direction, let's say. Okay, so this is plus 10. And the distance which it travels, we already know, right? So how much the distance it travels? 38.2 meters. Okay. So my S is also going to be 38.2 meters. Now we have three of them, right? U, A, and S, and all we need to find is the T. Okay. Now, how do we find that T? By simply using an equation which doesn't have B, right? So we can use S is equal to UT plus half A T square. Okay. Now U is 0, so this is going to be 0. So this is going to plus half A is plus 10 into T square, and this is going to be 38.2. So I'm going to take it on that side. So this is going to be 38.2 into 2 divided by 10, and then the T square. So let's use our calculator to find that value. So that's 38.2 into 2 divided by 10, and then we have to take the under root. Okay, so let's use our calculator. That's 38.2 into 2, 76.4 divided by 10. So that's going to be 7.64. So my T is going to be square root of that, right? So you can take the square root of 7.64. That's 2.76 seconds. Okay, 2.76 seconds. So how much is the total time, right? Is what we have to find. The total time is going to be the first time which we found, time A to B, right? And this was 0.8 seconds, right? From A to M, sorry. And then the time from M to S is 2.76. The total time in the air is going to be 2.76 plus 0.8 seconds. Okay, that is going to be into plus 0.8 to be 3.56 seconds. Okay, so that way we have solved the part 2. Okay. Now it is asking what is the velocity just before hitting the sea. But before we go there, I want to show you another way of doing this, right? So as you know, we started from here with the initial velocity which was upward. U was 8 meters per second. It goes up and then finally comes down, right? So in this process, we can say that for gravity, this is the positive direction, right? So my displacement here is going to be also positive, and this time it is going to be 35 meters, right? So my displacement S, if we write our U, V, S, A, T, my displacement we are going to say is 35 positive, because we are taking downward as a positive this time. We can say the acceleration, which is also 10 meters per second, is also a positive number. So we know two of them. And my initial velocity is 8 meters per second, but this is upward, so I will say minus 8, right? So we know three of the things, and because the acceleration is not changing throughout the process when it was going up or down, we can directly actually find time from here as well. Okay, so we can use the same equation. S is equal to ut plus half a t square. Now S is going to be minus 8. Sorry, S is going to be plus 35. U is going to be minus 8. And then my T will be T plus half into 10 into T square. Okay. So now this will go on that side, so it becomes 70 is equal to minus 16T plus 10T square. As you can see, now it's forming a quadratic equation, right? We are getting 10T square minus 16T, right? And minus 70 is equal to 0. We can solve this quadratic equation to find the same time T. Okay. If we try to one shot it, basically we have to solve this quadratic equation. Okay. And when you do that, basically we'll arrive at the exact same result. Okay. Now let's look at the part C, which says the velocity just before hitting the sea. Okay. So we want to know what is the velocity just before hitting the sea. Okay. We are interested in this V final. Now we already know in this way also, right? Our initial velocity U is minus 8. My S is 35. The A is plus 10, and we have to find v. So we can simply use v squared is equal to u squared plus 2as. Okay, let's do that. So u squared with minus minus equal to 64 plus 2 into a is 10 and s is 35. So we can do this 64 plus 20 into 35. Okay, so let's do this 20 into 35, that is 700 plus 64, that will be 764. Okay, and that's going to be v squared. So we are going to take under root of the 764 to find our answer, right? 764 under root, and that is going to be 27.6 meter per second downwards. Okay, so with that, we have got the answer of this one. Okay, now distance covered by the stone is pretty simple. How much distance it has traveled? This is 35 meter. Upward was 3.2. The total upward was start from here, right? So distance, we follow the path, right? Remember the distance depend upon the path. So this is 3.2, then back again 3.2 plus 35. Okay, so 3.2 plus 3.2 plus 35, that's 35 plus 6.4. Okay, so 35 plus 6.4, and that's going to be 41.4 meters. Okay, so that's the distance traveled. Now we have to find the average speed and average velocity. Okay, very interesting. So the average speed is going to be a very simple thing, which is going to be the total distance traveled, right? Total distance traveled by the total time. Okay, so how much is the distance traveled we found here? The total distance traveled is 41.4 meters. Okay, 41.4 meters. The time it took, we already calculated. Here, total time was 2.76 seconds. Okay, plus 0.8. So total time was 3.56 seconds. Okay, so we are going to divide it by 3.56 seconds. So my speed, which doesn't have any direction, by the way, right, is simply going to be 41.4 divided by 3.56 seconds, and that is going to be 11.62 meter per second. Now, the last part is asking for average velocity, right? So we have to stick to our basic. What is the average velocity? Average velocity is the displacement divided by time. Okay, total time. So how much is the displacement? The object starts from here, right? Let's look here. It starts from here, goes somewhere, and then come back here. So my displacement is like this one, right? So 35 meter downwards, 35 meters downwards. Okay. See, I am writing the direction as well because we are talking about velocity. Then we divide by 3.56. Okay. And what we are going to get is 35 divided by 3.56, roughly around 10, right? So we are going to do 35 divided by 3.56. That's going to be 9.8 meter per second downwards. Okay, so everything is in order. So this is how we can solve this problem. This is a very good problem which can clear the concepts of your understanding of the acceleration using different kinematical formulas, understanding the difference between speed and velocity, and things like that. So enjoy.